I got moves. I got moves, people. I'm a good dancer. Now, here's what we got going on today. We have a little bit of dun, 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 radial versus circular. It's a big fight, folks. Who you putting your money on? Who you putting your money on? Yeah, it's a tough call. Tough call. Actually, what we're doing here is describing the difference in symbols and when you will use those symbols and the units that we're going to need to use for when you hear the words radial versus circular. Now, these aren't the only words that can actually mean these. So, what I'm talking about here is, if you look at the old kinematics equations, we had the big three. Well, we can use the big three for things that are spinning around, but they have different symbols. Okay, you should have watched the video on that. Yes, you should have. You should have. And there are different words that mean we're going to have to use radians, hence radians. But if you see this word as well, angular. Oh. Yeah, I got that right. Angular, or if you see the word rotational. That's not a good marker. Let's get a better one. Rotational. Rotational. It's an Italian word. Okay, these three words mean something, and over here in the next corner, weighing 220 pounds, the rager from the cager. I don't know, I'm just making crap up here. It's all coming out from inside. It's what happens, you know. This happens. Circular, but we also have in this corner tangential. All right, centripetal, not centrifugal. Don't trigger me. Centripetal. And the word linear. Okay, what these mean are you're going to use these three here. You're going to use radians. This is where you're going to. This is talking about something spinning around on its own axis. This over here is talking about something going around something else. Okay, not on its own axis, but spinning around something else. And so if I see these words, sometimes you're asked to find the tangential or the angular velocity, tangential velocity. I would be using this stuff. What are you talking about? The units that we use when asked to find tangential or centripetal or linear or circular are meters per second, or meters per second squared. And that would mean you're asked to find the tangential distance, or maybe the centripetal acceleration, that's acceleration, meters squared, or maybe the linear velocity, meters per second. Those words here are coupled with those units, meters per second squared. Okay, now over in this corner, we have radial, angular, and rotational. If you're asked to find that, like the rotational velocity or the angular distance, all right, or the radial acceleration, those words mean you're supposed to use these units. Radians. It's so rad, man. It's so rad. Yeah, rad. Fire out, man. That would be, also let's go radians per second. So there's my distance in radians. My velocity would be in radians per second. So radians versus meters, radians per second versus meters per second, and radians per second squared. Radians per second squared. I'll make that a little neater. Okay, versus meters per second squared. So, depending on what question you're being asked would depend on which units you're going to use. So if you see these three words and you're asked to find one of these three things with an acceleration, a distance, or a velocity, then we have to make sure we use the units radians. if we're being asked to find an acceleration, a distance, or velocity with any of these words attached to it, then we're using meters. Okay, all right, okay. Muy importante grande. I hope you took that down, kids. I hope you took that down. Okay, so one other thing that's really, really important. Sometimes you want to switch from one to the other. What do you mean? Well, let's say we do this. Let's say we calculated that we got an angular velocity of something which is moving around something, and it ends up going at a velocity, so let's use the right unit. And, oh, that is terrible. That is terrible, terrible grande. Now let's try this one. Let's say, there we go. We have an angular velocity, okay, omega, that's what we use there. And that angular velocity ends up being 30 radians per second. Okay, all right. How fast is that? Is that fast? Is it slow? Is it like turtle? Or is that Speedy Gonzales? We don't know. How are we supposed to know? You don't know. What do you need to know?
How big is the radius?
Yeah, if I knew how big the radius is, in other words, it's the same thing as 30 radii per second. Remember, you watched my video, didn't you, on what a radian is? Good. If the radius of the circle that this is going around is little tiny and cute, just 1 little millimeter. Yes, you're just so cute, 1 little millimeter. Well, then that's not very fast. That's like sloth fast. Yeah, but if that radius is a kilometer, or that's 1,000 meters, whoa. That is the quickster fast, okay? That is the quickster. Some of you know what I'm talking about. You want to see me run to that mountain and back? You want to see me do it again? Yeah, that's the quickster. That would be like 30 times 1,000. That'd be 30,000 meters per second. That's fast. See, so it depends. It depends on what the radius is. So what we want to do, trust me, you do. You want this, is we need a gear shifter between the radian and the meter. How can I convert from one to the other? Here we go. Important equation. It's going to get a star here. Important. Velocity is equal to omega times r. Star over here. There we go. That is the gear changer equation. In other words, if I want to know how fast this is in a unit that I can understand, meters per second, because we get meters per second now, I think, enough that we understand how fast that would be if it's in meters per second, then I just take the velocity, radians per second, and multiply it by whatever the radius length is. Let's say the length of the radius is 1 meter. Okay, it's a 2 meter diameter circle, something spinning around. And so the radius is 1 meter. So 1 meter goes here. And, all right, anybody have a calculator? 30 times 1. Okay, all right, Billy, you got it? 30? All right, Billy, I'm trusting you. Billy, he's very angsty. You gotta be careful with him. So this is going to end up being meters per second because a radian is not a unit. It's a thing. So it's not a unit. I know that's very technical, isn't it? So this ends up being 30 meters per second. So all I have to do to figure out how fast something's going in a unit that I can understand, meters per second, is to multiply that velocity, the angular velocity, or rotational velocity, or radial velocity. They all mean the same thing. They're all synonymous. They're all synonyms. And we know what synonym is, right? We put that on our toast in the morning. So tasty and good, synonym. Yeah, and so we just multiply that by the length of the radius, and we have 30 meters per second, which you all know about how fast that is. Or at least you should. Remember, double it and add a little bit. So it's about 64, 65 miles per hour. Okay, that's pretty fast spinach. Boom, boom, boom. It's a lot of spinach. Popeye would like to eat all that spinach. Spinach, spinach. Oh, funny, funny. Okay, so now this is a very important equation right there. All right, you're going to need to know that. Yes, you will. Several of your problems for homework, you need to know that to do those problems. Now, one more. Uno más chicatos grande. If that's velocity, I'm going to get rid of these words now. Okay, we know this versus this. This is radians versus meters. Let's get these out of here. And I'll get that whole thing out of it. Oh, and one other thing too is you can also use this, of course, to find omega. So if you know what the velocity is going in a circle, the tangent velocity, and it's called the tangent velocity because if something was spinning around in a circle and suddenly whatever force was holding it in, centripetal, not centrifugal, force were to let go, it would go off at a tangent at some meters per second. So if we know what that is, we can solve for omega if we need as well. So it's a gear changer. If we know one, we can solve for the other. As long as we know the radial length, the radius length, as long as we know that, we're good. So that's another way of using that equation. All right, but let's take this and look at a very important equation that we use for centripetal. So over here, remember I had verses? I guess we'll put our verses back up here. I just took the words out to make room. But over here was centripetal, and centripetal acceleration is AC equals V squared over R. Okay. Now over here, we have acceleration using the words, radial, rotational acceleration. And acceleration is just different symbols. For basic acceleration, acceleration is change in velocity over time. So acceleration is change in velocity divided by time. There's an acceleration. This would be radial acceleration. This is centripetal acceleration. All right, here's what I wanted to point out. Because using this equation, V is omega times R, we can make a substitution in here. Get rid of this, keep this down here. Our important equation, keep that, okay? And go ahead and make a substitution in here. And I can write centripetal acceleration as, well, V is omega times R. V is omega times R squared divided by R. Okay, now check it out. Squaring both. You get that. You get that. You see it, yes you do. You're all relatively intelligent people. We get that. This is using the centripetal acceleration equation in terms of an omega. So what does that mean? Why would I want that? Well, what if you were given the radial velocity, the rotational velocity, the angular velocity? I'm using these words. And you wanted to know what the centripetal acceleration is. Or maybe you want to know it's sometimes called a linear acceleration. It's kind of weird, but when we're talking about circular. Or maybe the circular acceleration, or thinking of those words we had over here. And I don't have this velocity. Well, you have two choices. You can take this, put it here, multiply by the radius, get your V, put it in here, and solve. Or you can save yourself a step and go ahead and put it right in this equation here. These are the same equation. They just don't look the same, but they are. And this one sometimes comes in handy-dandy notebook. Blue's Clues. Great show. Okay? We just got a letter. We just got a letter. We just got a letter. I wonder who it's from. Oh. So either one of these will get you the same answer. But sometimes this one comes in, well, like I just said, handy-dandy notebook. And if you have an omega, you can square it and multiply it by the r value, and you will get centripetal acceleration. You will get the same darn thing, because this will end up being, okay, a unit over second squared times a distance, which is meters, and you'll get meters per second squared. It's just as you'll get a meter per second divided by meters, you get a meter per second squared. Both of them get you the same units. It's just a different way at arriving at the same answer. In one of your homework problems, number seven. Very much like that. And I think, let me look on the board here. Number nine, and number 11. Yeah, it's really handy to have that version of it. So, yeah, there we go. So they're just showing you that we can use what I call gear changers, shift between one word, radians, and another word, meters, and we can use our equations interchangeably between each other. So sometimes you'll be asked maybe to find the angular acceleration in radians and then a centripetal acceleration. And if I know the angular velocity, I can just go ahead and make a quick substitution in. And we'll do an example problem like this. Okay, I will do a POD, a problem of the day, like this. And yeah, so you'll see what I'm talking about in an application. Okay, I think that's going to make like a gift and wrap up this video here. We'll cut this one off and say, adios, muchachos.